Hello everyone, welcome you all for the video lecture of the topic Interprocess Communication in Operating System. The process can be categorized into two types, independent and cooperating. Cooperating process will be affected or it will affect other process including the sharing data. Reasons for using cooperating process are information sharing, computation speed up, modularity and convenience. Cooperating process needs a mechanism for communicating with each other, and the mechanism will be interprocess communication. There are two models that are used to implement IPC. They are shared memory and message passing. The diagram depicts the two models. First one is message passing and the second one is shared memory. In message passing system, there will be of two process which wish to communicate with each other, will be sending the messages to each other, and the messages will be initially placed in the message queue, and with the intervention of the kernel these messages will be passed among the processes. In the second diagram we can observe that there is a shared memory between the process A and B, where this memory will be utilized by the both of the process for communicating with each other. The next topic is producer consumer problem. This is a paradigm for cooperating process which involves two process. One is producer process and another one is consumer process. Producer process is meant for producing information and the consumer process is meant for consuming the information. The information will be placed in a buffer which is a temporary storage. So the buffer can be categorized into two types, unbounded and bounded buffer. In unbounded buffer, there will not be any size limitations, and in the bounded buffer, the size will be fixed and limited. So this is a code snippet to depict the shared memory solution. That is, we have defined the size of the buffer to 10 and we have two variables in and out which will be initialized to 0. This is the code snippet that shows the producer process. Here, whenever the producer is producing some information and placing it over the buffer size will be incremented. This is the code snippet for consumer process. Here also, whenever the consumer process is consuming the information, the size of the buffer will be incremented. Now we are going to discuss about the shared memory. So it is the area of memory that is being shared among the process that wants to communicate with each other. Here, the control of the communication will be completely under the user process rather than the operating system. The major issues that are being faced while implementing this mechanism is allowing the user process to synchronize their actions when they access the shared memory. So there should be some mechanism for process to communicate and to synchronize their actions. Message system will have the process that will be communicating with each other without resorting to shared variables. IPC facility can be implemented using two operations. One is send of message and another one is receive of message. Here the size of the message can be of fixed or variable. If the process P and Q want to communicate with each other, initially they need to establish a communication link between them. Then only the exchange of messages can be done using the send and receive operations. While implementing this system, there may be certain issues that will be occurring. There are some issues like how the links can be established between the process and how the link can be associated with more than two processes. There should be information regarding the link can exist between every pair of information, and if there is any limitations on the number of links to be associated with each process, and the size of the message that should be passed over the link should be mentioned, as well as there should be information related to the link that may be either bidirectional or unidirectional. So the implementation of communication link can be done using physical or logical. So physical includes shared memory, hardware bus and network, and the logical method includes direct or indirect method, synchronous or asynchronous, automatic or explicit. Now let us discuss about the direct communication. Process must name each other explicitly, so that the process name should be specified as the first argument in the send and receive operations. So here we have send of p comma message, where p is the name of the process and message that needs to be communicated to the receiver process. Receive of q comma message, here q is the name of the process from where the recipient process has to receive the message. There are some properties of the communication link. They are: links are established automatically. A link should be associated with exactly one pair of communicating process. Between each process, how many links can exist? And the link may be unidirectional, but usually the bidirectional links are used in this type of communication. Next type is indirect communication. So the messages are directed and received from mailboxes, which can be also referred to as ports. Each mailbox will consist of unique ID, and the process can communicate only if they share a mailbox. There are some properties of the communication link under this category. Link established only if the process share the common mailbox. A link may be associated with many processes. Each pair of process may share several communication links. Link may be unidirectional or bidirectional. So the operations that are carried out in this indirect communication are: creating a new mailbox using the port, send and receive the messages through mailbox, and finally destroying a message box mailbox. So the primitives used under this communication are send and receive. Here, instead of specifying the process name, we have to specify the name of the mailbox as the first argument, and followed by that message has to be specified in this operation. Next topic is about synchronization. While using IPC, the activities of both the sender and the receiver process needs to be synchronized in order to avoid any conflicts, or in order to avoid any issues that will arise during the communication. So the message passing can be implemented either blocking or non-blocking. Blocking method will be considered to be synchronous. So there may be blocking send or blocking receive. In blocking send, the sender has to be blocked until the message is received, and in the blocking receive, the receiver is blocked until a message is available in the buffer. In non-blocking system, the communication will be asynchronous, either non-blocking send or non-blocking receive. The sender sends the message and continue. Non-blocking receive, the receiver receives a valid message or a null message. Now let us discuss about the buffer. So the messages will be stored in a queue called buffer that are attached to the link. This buffering can be implemented in any of the three ways: Zero capacity, bounded capacity, and unbounded capacity. Zero capacity means no messages are queued on the link. Directly the sender will send the message and it will wait for the receiver. Bounded capacity, the buffer will be of finite length that can have the capacity to store only n number of messages. The sender must have to wait if the link is full. In unbounded capacity, the length of the buffer will be infinite and the sender never waits the receiver. Next topic is communications in client server systems. The communication can be achieved by these following four techniques: sockets, remote procedure calls, pipes, and remote method invocation. Now let us discuss about the pipes. It acts as a conduit to allow the two processes to communicate with each other. There are some issues that will arise in pipes also. Is the communication unidirectional or bidirectional? In the case of two-way communication, whether it will be half or full duplex, there must exist a relationship between the communicating process. Can the pipes be used over a network? The pipes can be of two categories: ordinary pipes and named pipes. In ordinary pipes, it can't be accessed from outside the process that created it. Typically, a parent process creates a pipe and uses it to communicate with a child process that has been created by the parent. The named pipes can be accessed without a parent child relationship also. Here, this is the diagram which depicts the implementation of ordinary pipes that will allow the communication in standard producer-consumer style. The producer writes in one end and the consumer reads from the other end. Ordinary pipes are therefore unidirectional. It requires the parent-child relationship between the communicating process. Named pipes are more powerful than ordinary pipes. Communication is bidirectional. No parent-child relationship is necessary between the communicating process. Several processes can use the named pipe for communication. It is provided on both Unix and Windows systems. Thank you for watching the video.